Somewhere in a small population thousands of years ago, one tiny mutation flipped a switch. Suddenly, a handful of humans looked completely different from everyone around them. Most of them lived in exactly one part of the world, and scientists still argue about why. Today, less than 2% of people on the planet have naturally red hair. It's one of the rarest traits a human can be born with. But the story of where it came from is a lot stranger than just genetics. Let's start with the gene itself. Red hair comes down almost entirely to a single gene called MC1R. This gene controls how your body produces melanin, the pigment responsible for hair and skin color. In most people, MC1R produces a type of melanin called eumelanin, which creates brown and black tones. But certain mutations in this gene switch production over to a different type, called pheomelanin, which produces red and orange tones instead. Here's the part that surprises people. This isn't a new trait that showed up recently. Genetic researchers have traced red hair causing mutations in MC1R back over 500,000 years, long before modern humans as we know them even existed. So this mutation was already floating around in ancient hominin populations well before Homo sapiens spread across the globe. Which raises an obvious question. If the trait is that old, why is it so rare today? The answer comes down to basic genetics and geography. MC1R mutations are recessive. That means you need 2 copies of the gene, one from each parent, to actually end up with red hair. If you only get 1 copy, you become a carrier, but your hair stays brown or black. This alone makes the trait far less common than dominant traits because it can hide silently in a population for generations without ever showing up. But recessive genetics alone doesn't explain the geography. Red hair today is heavily concentrated in Northern and Western Europe, especially in populations with Celtic and Germanic ancestry. Scotland and Ireland have some of the highest concentrations of the trait anywhere on Earth. So why there specifically? This is where sunlight comes back into the picture, but not in the simple way most people assume. Northern Europe has weak, indirect sunlight for most of the year. Human skin needs UV exposure to produce vitamin D, which is essential for bone health and immune function. Populations that migrated into low sunlight regions faced consistent evolutionary pressure toward paler skin, because pale skin absorbs more of the limited UV available. And it turns out the same MC1R mutations that cause red hair also tend to produce paler skin that burns easily rather than tanning. In a high sunlight environment like Africa or the Mediterranean, that combination would have been a serious disadvantage, leaving people more vulnerable to UV damage. But in a low sunlight environment like Scandinavia or the British Isles, that same trait may have actually helped early populations absorb enough vitamin D to survive and reproduce. In other words, the same mutation that would have been a liability near the equator became a quiet advantage the further north early humans migrated. But there's a twist that most people don't know about, and it involves a completely different species. In 2007, researchers extracted DNA from Neanderthal remains and found something unexpected. Neanderthals had their own separate mutation in the MC1R gene, different from the one in modern humans, but one that would have produced a similar reddish coloring. This means red hair likely evolved independently at least twice in human history, once in our own species and once in Neanderthals, in 2 completely different genetic pathways that just happened to land on a similar result. That's not a coincidence you'd expect. It suggests that in certain environments, whatever pressure was pushing toward lighter pigmentation was strong enough that 2 entirely separate branches of the human family tree landed on the same rough solution. So by the time modern humans were expanding into Europe, there may have already been a version of this trait present in the Neanderthal populations they eventually interbred with, adding even more complexity to how the mutations spread and mixed across ancient populations. Which brings us to today. Red hair survived not because it was common, but because it managed to hide in a recessive gene for hundreds of thousands of years, occasionally resurfacing whenever 2 carriers happen to have children together. It's rare enough that most people who carry the gene never actually see it expressed in their own hair color. It just sits there, quietly passed down, waiting for the right combination to show up again. So the next time you see someone with red hair, you're not just looking at a hair color. You're looking at a 500,000-year-old mutation that outlasted an entire other human species, survived migration across continents, and somehow still shows up today in less than 2% of the population, a trait more ancient than most of what we consider modern about being human.